Hello, welcome back. In this segment, I will explain the core idea of Miller-Rabin very briefly without going into all the mathematical details. Okay. So in the case of Fermat-Euler, we were only looking at the last column of this table. Okay. And we looked for some witness. For example, witness number 2 is a witness because 2 power 20 is 4, which is not equal to 1. We look at only this column. And if we find a row which has the last column value not equal to 1, then we claim that element is a witness. For example, 2 is a witness, 4 is a witness, 5 is a witness, and so on. Okay. The idea of Miller-Rabin is not only look at the last column, but look at a sequence of columns. Okay. And it is making use of some interesting properties. If a number is prime, okay, if you consider this equation x square is equal to 1 mod n, okay, what are the possible square roots, either plus 1 or minus 1, okay? And if you get anything other than plus 1 and minus 1, then we know for sure the number cannot be prime. So that's the one idea it uses, okay? And it also uses other idea that if you start with plus or minus 1 and keep squaring, you will definitely end with 1. So that number is not useful for a witness. So it defines a witness in a slightly different way than Fermat-Euler, okay? It defines as follows. It takes the given number n and rewrite it as follows. Suppose in this case n is 21, we rewrite n as, okay, it doesn't matter whether small n or capital N. We write it as 2 power r times u, which means if n is 21, what can we do with this? This is nothing but, this is 20, right? Which is nothing but 2 power 2 times 5. Okay. So it's going to look at the sequence of numbers as follows. It's going to look at a power u, a power 2u, a power 2 square u, all the way until, this is 2 square u, all the way until a power 2 power r minus 1 u. Okay. By the way, if you include a power 2 power r u, you will get a power n minus 1 because that's how we defined n minus 1. So what is the property that it's going to look at? It's going to look at this. It checks whether this number is plus or minus 1. If it is plus or minus 1, there is no point in continuing because if you square a plus or minus 1, you will always get 1. So it will not continue if the first element in the sequence is a plus or minus 1. All right. Let's assume it's not a plus or minus 1. What are the other properties it's going to look at? It's going to look at this sequence and it checks whether each element in the sequence is different from minus 1. What is the reason it's doing this? Okay, let's think about it. If each element in the sequence is different from minus 1, it can be 1. Let's assume this element is 1 for a moment. Okay, you know, this is not a problem. The reason is if this element is 1, every element after that will also be 1, including the last element. But there's an interesting property. This is the first time we're seeing 1, right? And we ruled out the possibility that the previous element in the sequence is not plus or minus 1. Okay, what does that tell us? That is telling us the fact that the number n must be a composite number, because if it was a prime number, the only possibility we will get 1 is squaring a plus 1 or minus 1. But we ruled out the possibility that the previous element is not a plus or minus 1. Okay, so sequence of ones is perfectly fine, provided the first element is not plus or minus 1. That's the idea it uses. Okay, look at the structure of this table now. For example, take the number 8. Okay, 8, the power of 8, if you look at it, the last column is 1. Okay, yet 8 is a witness. The reason is as follows. We rewrote 21, right, as 21 minus 1 is 20. It is nothing but 2 power 2 times 5. So we look at the fifth column, which is here. Fifth column is 8, right? Remember that formula that we wrote. We rewrite n as n minus 1 is 2 power r times u. Okay. And in this case, r is 2 and u is 5. So we will be looking at a power 5. A, for example, a is 8. So we look at a power 5 is this term. And this is not equal to plus or minus 1. So we will continue. The next term we will do is square of it, which is the 10th element, which is this, which is still not plus or minus 1. We stop. Okay. Even if you include the last element is 1. but the previous element was not -1, that tells us the number 21 must be a composite number. This is because, again, recalling this equation, x square is equal to 1 has two roots if the number n is a prime number, plus or minus 1. But if we have ruled out the previous number is not -1, and we assumed that the previous number is not 1 because this is the first occurrence of 1, that means this element must have been other than 1 and -1. That means the number is not a prime number. Okay, the number 21 is not a prime number. So that's basically the idea. We are going to look at the sequence of numbers, a power u, a power 2u, and so on, and look at whether anywhere in the sequence we get this property that we are able to find some number which is going to end with either a not 1, the last column not 1, or if it is ending with a 1, the previous element in the sequence is not plus or minus 1. That's basically the idea of Miller-Rabin. Thank you very much.